Hi everyone, welcome back. In the previous videos, we have seen the concepts of deadlocks, guys. Hope you got the clear-cut idea about deadlocks and you understood various gate-related problems of the deadlock. From now onwards, we will try to read or study the concepts of memory management, where in memory management you are going to know how the processes are allocated in the main memory. We are going to mainly discuss, but before going for the actual concepts of the memory management, let us try to revise two concepts like linker and loader, which you have already studied in a subject called compiler design, guys. Okay, without wasting much time, let us dive into the concepts of linker and loader. Guys, generally, if you would like to write any kind of a program, like that program can be anything, like let us say C program, where C program is going to extend with .c. To write this program, you need some kind of editor. And once you have written it, you are going to save the file. Then you are going to compile it. Once you compile the program, what you have written, it is going to generate an object code, which you can able to observe as .obj file. Generally, this .obj file contains the instructions in the form of ones and zeros, right? So, which can be understood by machine. But object code is different from the executable file. Object code cannot be executable executed directly, whereas coming to .exe can be executable file. Okay, fine. Where this object code will reside, where the object file will reside, it will reside in the hard disk of the system generally, right? When you are under the execution, then some particular software will load the object code which is available in the hard disk to the main memory. That is what we call it as executable file. Okay, so if you look into how the object code will be, like this object code contains various parts, guys. So let me take a structure so that you will get the clear idea. The first part of the object code will be header, where the header will maintain what are the various parts available in the object code, and their references will be maintained by the header. I mean, in general, if you look into the object code, it contains many segments are there. The other segment will be code, or I can call it as text segment. Another one will be data segment. Next one will be relocation information. Next one will be symbol table representation, and the final will be debugging info, guys. So the header part will define what are the various parts that are available for us, like code part, data segment, relocation information, symbol table, debugging, etc. Right? And where they are located, like they are located 100 reference or 200 reference or 300 reference, which address they are going to be located, that will be maintained by the header part. Coming to the code or text segment, here in this location, all the instructions what you have written will be maintained. And coming to the data segment, which will maintain what are the constants that you are using inside the program will be maintained here. And coming to debugging info, how you are going to perform the debugging, right? So when you are going to perform the debugging, the related information is going to be maintained at the debugging information, right? So we are majorly concentrating on these two parts of the object code. One will be relocatable information, another one will be symbol table, right? So let us try to look into this relocation information. Try to observe, guys. Generally, when you are going to write a program, let me say this program might contains various kind of labels, like let me say as L1, and you might use a keyword called go to keyword and try to define it as go to L1. This is a general C program. I am saving it with .c, extended with .c. Now you are in a position to compile it, right? To compile, then the respect to obj file will be generated, right? Obj file will be generated. Now this object file contains relocation information, right? Something like 1 and go to 1. What is the meaning of this one? I simply replaced L1 with 1, means at which address the L1 is located, right? So which we can call it as during the conversion from normal program to dot object code, all the labels are converted into respect to addresses, guys. Generally labels are meant for our purpose only, not for the system purpose, right? So to make it understand by the user, we are using the labels or variables like that, but finally system has to understood where they are available in the form of addresses only, right? Means during the compile time, what is going to be happen? All the symbolic names what we are using converted into relocatable addresses. Good. Hope you understood. This is what happened at the compile time. But the thing is, so for example, this is our memory. Our main memory, where OS will reside, and the program, like let me say j.obj is loaded at this program file, and I can call it as .exe, guys. .exe. At that point of time, this will be the 1 and go to 1 will be okay. But like that, we are going to have many number of programs we are going to write, like 1, which will be again go to 1. I mean, if I say L2 and I made the name as L2, go to L2. This one was rewritten as what? The respect to address of the L2 1. Now, if I am going to load j.exe, or if I say k.obj, and if I say this is k.exe, right? So go to 1 means, right, if I written here as go to 1, is there any specific meaning for this? No, because the 1 address is common at 1 location over the entire memory. Am I right? If you are able to clearly understood, 1 address will be only at 1 location. So with respect to j it is okay, but with respect to k, go to 1 means it is trying to access outside of the other program data. That is an incorrect. So what will happen? So when we are going to have many process with the same address 1, it might be loaded to some other location, right? So if you want to overcome this one, what you can do now? So for each and every location, for example, let's say this address starts with 100k, this address starts with 200k. Then you have to be in such a situation that this will be 1 and go to 1. If starts with 100k, you have to be rewrite this go to 1 as go to 100k plus 1. The reason is its initial address is 100k and I want to move to 100k plus 1. What about this one? If I say the for k, you have to be right in such a situation that go to 200k plus 1. That's a better option, right? So now this address will be call it as final address, or I can call it as absolute address, or another terminology I can call it as relocation, right? So what is the meaning of a relocation? Relocation means converting one form of address into another form. One form of address into another form, we can call it as relocation. Right? The actual address will be the relocation address, and the address what we are finally generating is called as absolute address. But guys, just think about it. During the compile time, are we really know where the program might be loaded? Definitely not, right? So if it is not known at the compile time, we can call it as runtime binding, right? If you know any program where it will be loaded at the compile time, we call it as compile time binding. But in general, it couldn't possible to know where the program might be loaded, right? Only the operating system will know that will be given by the given to the loader. Then loader will able to know and where it will be loaded. That will be defined by the loader, right? Which means that here, if you are going to know the way the program might be loaded, that will be called as compile time binding. If you don't know the compile time, we call it as runtime binding, right? So as a programmer, a program might contain various kind of relocatable addresses. All these relocatable addresses, right? All the relocatable addresses, you have to maintain that location. We call it as relocation info. That is where here you are going to be maintained. In the location information, all the relocatable addresses will be maintained, right? So here you might get the question, who will done this relocation? The loader is a software which is responsible for relocation. Okay, fine. So basically the loader is meant to load the program from hard disk to the main memory. This is one of the advantages, and another one is which is meant for the purpose of relocation. Okay, fine. Next segment, that is a symbol table. Hope you understood up to now. Symbol table, guys. The symbol table will contain all the symbols what you are using inside the program, right? So something like all the variables, all the methods, or we can call it as procedures, right? Those procedures can be any kind of user-defined procedures, or any kind of predefined function procedures. All those things will be maintained at the symbol table. For example, let us say there is a function called call one function, right? As this is a kind of user-defined function, I know its address, so that address I am going to maintain here. And suppose, for example, if I am having a function called printf function, right? Do we really know where this function will be existed? No, we don't know, right? Printf is a predefined function which we don't know. So means we can call it as it is a kind of unresolved one, right? We don't know exactly where they are. So what you have to do now, before going to run the program, we have to rectify all the unresolved symbols. Right? So who will be the responsible for to rectify all the unresolved symbols means the linker. Linker will rectify all the unresolved symbols. Hope understood, right? So means what is one of the purpose of linker, which is meant for to work with the various kind of symbols, means I can say that to resolve various kind of symbols. I can call it as symbol resolution. And another one will be, guys, again relocation. Right? Why again the relocation can be done here means, let me tell. Here the relocation will be done by the loader as part of the static linking. Am I right? As part of static linking. But in real world, the linking can be done. Relocation can be done at the runtime. When it happens at the runtime, it has to be known, right? So who will done that? That will be done by this linker. For example, if I say there is an object file which I have written like j.obj, and there is an object file I can call it as k.obj, right? If it contains various kind of function calls like I can call it as abc, I can call here as de, okay, and which is also going to call some of the predefined functions called printf, guys, right? So if I say this is one object file and this will be one object file, and there will be a kind of user libraries. User libraries means what? All the predefined code which are written by the user, right? A, B, C, D, E, right? So these are all the various kind of things. Now what the linker will do next? The linker will take all the things and try to combine them into a single one. Try to combine them into an object code where it contains the single file. Right? This is what we call it as link time, guys. Link time. So link time means all the relocation addresses will be combined into a single module, which we can call it as link time. Means at link time what will happen? Relocation addresses at various kind of modules, like A, B, C, D, E, all those things will be combined into a single module. This will be happen. Okay, fine. So now what is there here? Like something A, B, C, D, E, and something like printf is also there, right? And all the things happens, their addresses, something like address can be 10, 20, 30, 40 and 50, which are done, which are static link, right? We already know. But coming to kind of predefined functions, right? They will be known only at the loading time. So that thing has to be identified again, which is again I can call it as unresolved references. Guys, generally this linker also happens, it works in two phases. In first phase, it is going to check with various kind of segment tables and symbol table, right? So which means what are the segments which are loaded or which have to be loaded will be defined by the segment table. And coming to symbol table, it is going to identify what are the symbols that need to be resolved will be defined by the symbol table. And coming to the, this will be done at the first phase, and coming to the second phase, it will resolve all the unreferenced references, unresolved references, right? Unresolved reference means that again it has to perform again what? Relocation, right? So based on this explanation, hope you understood why relocation is again happening at the linker also, right? So to make it understanding of this one, I have taken this entire process, right? Fine. Hope you understood here clearly about the linker, the loader, guys. Fine. Thank you.